Hello guys. How do you decide which way will a reaction go when you have a mixture of reactants and products? Well, we can calculate the so-called reaction quotient and compare that to the equilibrium constant to figure that out. The reaction quotient is calculated literally the same way as the equilibrium constant, but we are going to use the current conditions, not necessarily the equilibrium conditions. So when we are calculating the equilibrium constant using this expression, we have equilibrium conditions. And for the reaction quotient, we just take a look at the reaction. It might not equilibrate it might be going still into one direction. So we are using the current conditions. Now, we know that in nature, everything wants to be in equilibrium. And because the reaction quotient is calculated the same way as the equilibrium constant, when these two values equal to each other, we will be in equilibrium. So in this figure, if the reaction quotient is the same amount as the equilibrium constant, just like here in the middle, we are going to be in equilibrium. Now, what happens when we have a smaller reaction quotient compared to the equilibrium constant? Now, if we look at the expression for QC, we see that in the numerator, we have the concentration of our products, and in the denominator, we have the concentrations of our reactants. So if my Q is a small number, that means that I don't have enough products, right? The volume in the numerator is going to be a small number compared to the volume in the denominator, the amount of reactants. So when my Q is smaller than my K, the reaction actually will go towards forming products to the right. What happens when my Q is actually larger than my K? So Q larger than K. Well, in that case, I have too much of my products and the reaction should go to the other direction, to the left, towards the reactants. All right, I hope this makes sense. Let's do a practice question. So here we have at 600 degrees Celsius an equilibrium constant of 51.4 for the following reaction. Now we have to predict the direction of the reaction. If we start with 5 moles of HCl, which is our product, 2.5 moles of H2 gas, and 4 moles of Cl2 gas in a 1-liter container. Well, it's pretty convenient to have a 1-liter container because 5 moles is going to translate into 5 mole per liters right away. So let's calculate the QC first. So the expression will be the same as the expression for the equilibrium constant. So QC equals the concentrations of our products where we have HCl, and we need to square this because of this 2 right here, divided by the concentration of H2 multiplied by the concentration of Cl2. So remember that these are current conditions, not equilibrium conditions. Now we just need to plug in the numbers. We have 5 mole per liters of HCl. So 5.0 mole per liters of HCl. We need to square this up. Divide that by 2.5 mole per liters, which is molarity of H2 gas, multiplied by 4.0 mole per liters of Cl2 gas. And if you do this calculation, you are going to get 2.5. Now we can compare the value of QC with the value of KC, and it is visible that QC is actually smaller than KC. So this means that we need to make more products, so the reaction will proceed to the right towards the product. All right, I hope this makes sense. See you in the next video.